Okay, this video is a demonstration of how solving rational equations. So let's go over again what a rational equation is. A rational equation is basically just equations that have fractions in them, except these fractions have polynomials. In this particular one that I'm going to show you here, the polynomial is just a binomial, so it's pretty straightforward, but it should help you with your homework later on. Okay, if this were a fraction equation, let's say I had something like 1/2 plus 1/3 is equal to 1 over x. How would you solve that? What would you do? You'd probably want to find a common denominator, wouldn't you? So the common denominator in this little demonstration here off to the side would be 6x. That would be called the lowest common denominator. I don't know if you can see that. There you go. Now you can see it. So ask yourself, what can I multiply this 1/2 by so that the 6x will be in the denominator? And the answer would be 3x, wouldn't it? So let's multiply this first fraction by 3x over 3x. Now why would I do that? Well, multiplying by 1 doesn't change the 1/2, does it? But it does change what it looks like. That ends up being 3x over 6x. And that's actually the same thing as 1/2. So really you've just transformed the 1/2 into the 3x over 6x. Now you're going to do that to the same thing to the other two terms. Again, with a purpose of trying to get 6x as your denominator. So what am I going to multiply this 1/3 by? Again, the answer would be 2x, wouldn't it? 2x over 2x. So let's go ahead and multiply that out. And I get 6x here. And what would I multiply the 1 over x by? And the answer would be 6 over 6. So now I have 6x over 6x, which is 6 over 6x. Let me just get rid of that x on the top. There we go. Now what you've done is you've taken your first equation, and now you have the same base or the same denominator in each one of the three. And what you want to do at this point, which is kind of neat about this, is you get to cross out the denominators. And then your answer becomes 5x is equal to 6, or x is equal to 6 over 5. Now what you're going to do is you're going to take that exact same procedure and now just do it with polynomials. Okay, and it doesn't make any difference how difficult the polynomials are. As long as you have them factored, you should be able to get the common denominator. Now when I look at this problem over here, ask yourself, what's the common denominator? What's the least common denominator for both of those? And the answer would be 3 times a plus 6. Right? So you just kind of take this and multiply by this side, and the a plus 6, and multiply it on that side. And remember, you have to put it in a form of a 1, don't you? So let's do that. Let's multiply this side by 3 over 3. And let's multiply this side by a plus 6 over a plus 6. Now when you look at those two denominators, they're exactly the same. So let's cross them out like we did in the little demonstration off to the right and rewrite what's left over. You've got 3 times a minus 4 is equal to 1 times a plus 6. So I'm just going to put a plus 6 because I don't really need to multiply it by 1, do I? Okay, let's continue. Now, this becomes a lot easier problem than the original one. I'm going to get 3a minus 12 is equal to a plus 6. And at this point, let's just go ahead and get everything on the variables on one side, the numbers on the other, and we'll be able to solve for our final answer. Let's subtract an a. Let's add 12. Let's divide by 2. A is equal to 9. And that would be the correct answer. Now don't forget, you also have to find the restrictions. Remember what the restrictions are. It's any number that you put into the variable that makes the denominator equal to 0. You have to restrict that number because dividing by 0 is not allowed, is it? So you're going to go back up to the original and say, okay, a plus 6. If I put a negative 6 in there, that would not be allowed. So that would be my final answer. A is equal to 9. And a cannot equal negative 6. Okay, now that was a fairly easy rational equation. Let me show you something a little bit more complicated, something you might find on a quiz or on a homework or something. Okay, let's take a look at this one. Now that looks pretty formidable, but it really isn't. Just take each one of these denominators and find a common denominator. The way you do that is by factoring each one of those. So if you look at that denominator, you see that it's a regular trinomial, don't you? Let's factor that. I would say x minus 3, x plus 1. Let's look at that denominator. That looks like a difference of squares. So I'm going to say x plus 1, x minus 1. And if you look at that denominator, again, it's just a trinomial that you can factor regularly. That's going to be x minus 7, x minus 1. Okay, now compare all three of these denominators. How can I make them the same? Well, notice that they all have, well, actually not quite. This one's got an x plus 1, x minus 3. This one has an x plus 1, x minus 1. And this one has an x minus 7 and an x minus 1. It looks like the common denominator is going to be, let me add these up, x minus 7, and what's missing over here, an x minus 1. That looks like the common denominator. So I'm going to supply the missing factors over to these terms as well, right? So what's missing in this second one? Looks like an x minus 3. Starting to run out of room here, but you get the right idea. And it looks like an x minus 7. I'm just going to put that there and there, knowing that it's just a 1. And over here, it looks like an x minus 3 is missing. And it looks like an x plus 1 is also missing. A little bit off the chart there. Okay, now the good thing about this is I get to cross out the denominators. Because once the bases are all the same, once all these denominators are the same, you've made the numerators proportional. Okay? So let's cross them all out and rewrite just what's up in the numerator. That's going to be 3 times x minus 1, x minus 7, minus x minus 7 times x minus 3. Again, I don't have to put the 1 there. And over here I got 2 times x minus 3, x plus 1. Actually, believe it or not, that's simpler. That's a little bit easier problem to do than this one. What you're going to have to do is FOIL each one of these. Don't forget you're subtracting everything that follows. So I'm going to put that in a bracket. You're going to have to FOIL each one of these, add up all the like terms, and see if it simplifies at all. Let's try that. So let me see. You do these one at a time. So that's going to be 3x minus 3 times x minus 7. That's going to be 3x squared minus 21x minus 3x plus 21. That's that foiled. And then minus, let me put this in a parentheses again, x squared minus 3x minus 7x plus 21. Over here, it's going to be 2x minus 6. And now I can FOIL those two. That's going to be 2x squared plus 2x minus 6x minus 6. Wow. Kind of complicated looking. Let's keep on going here. I think the thing I need to do now is probably distribute that negative first and start adding up my like terms. Minus 21 minus 3 is minus 24. Let's distribute that negative. That'd be negative x squared. That'd be minus 10, so it's going to be plus 10x minus 21. Over here it's just going to stay the same. actually minus 4x, sorry, minus 6. Let's gather up terms some more. 3x squared minus x squared gives me 2x squared. Negative 24x plus 10x is a negative 14x. And the 21s cancel. Over here, looks like it's going to stay the same. That's my 7th step. All right, now, let's subtract 2x squared from both sides. Both of those will go away. All of a sudden, what looked like was really difficult is becoming kind of simple. Let's add 4x to this side. That gives me negative 10x is equal to negative 6. Let's divide by negative 10. X is negative 6 divided by negative 10, which turns out to be 3 over 5. So x is equal to 3/5. Now, you're not quite done. What are the restrictions? How do you figure those out? Go back to the original problem and look at the factored forms. Say, what are each one of the x's that are going to make the denominators equal to 0? So x cannot equal, if you look at that one, cannot equal a positive 3, cannot equal negative 1, cannot equal a positive 7, and cannot equal a positive 1. And that is your answer. Okay, I realize I went through that kind of quickly, but you should be able to go back through the video and just to check and see what each of the steps were. Just think of subtracting and adding regular fractions with numbers, and just do the same procedure with polynomials, and you should be okay. All right, good luck.